And we all thought of maybe doing a session like this because there's a stage in kind of, it's only, you've been doing ML research for a very long time, but if you compare that to the amount of time we've been trying to put these complex models into production, that's a lot shorter. And I remember when I started working in production, I was like, oh, this is cool, I'll just Google it, someone must have done this. And then you're like, oh my gosh, why is no one talking about this, you know? Why is no one talking about reproducibility? Why is no one talking about explaining things? Why is no one talking about this? And we thought, well, maybe you guys have questions too like that. So we put out the survey. We've gone and addressed what we needed to do, addressed your problems, and we are going to try help you, if not provide the exact answer, but give you a starting point. And often, as has been stated, the starting point is often more important. Cool, so I'm Jade. You probably know me from Twitter, but actually in my day job, I build NLP systems. Specifically, quite a novel area at the moment. So originally was semantic relatedness, and now we've moved on to mining chats and what we can learn about arguments and what we can learn about emotions, which is quite cool. And yeah, I've been putting those into production for about 3 years. Oh, and my tech stack was, we started off with a like Spark kind of tech stack and ditched that because it was terrible. Had memory leaks, and we've moved over to a very simple kind of TensorFlow based, you know, on a GPU, and we use Travis for CI. We're using a bit of Docker, and also work primarily in Python, and that interacts a lot with Golang. So that's my current stack.
Yeah, hi again. Well, I'm Daniele, you've heard me for a while, so. And as I mentioned before, I'm really interested in NLP. We're doing some interesting things around networks at the moment, which is quite difficult and interesting. So to be honest, lately the main thing that I've been doing is actually the R of the R&D. I've been kind of preaching the other side. And I'm just using some interesting NLP library to do stuff with that. It's not yet pushed in production. As soon as it is, I'll let you all know about what stack we'll be using. It will probably be something quite simple with Dockers and some Pythons.
My name is Tempest van Skyke, and I work at Microsoft, actually kind of in an Azure team. So I help Azure's customers build machine learning models and get them into production. So our customers might be like a pharmaceutical company or a hospital. And so I use actually whatever tech stack they use. So as long as they're using Azure for data storage and Azure for compute, then we are compatible with all open source technology. So mostly Python is popular. Some customers, especially in government, still use R. We often use Docker. If we might use Azure container instances or Azure Kubernetes services, so we use quite a lot of Kubernetes. What else? We use Azure DevOps, which is like for pipelines and CI/CD, but it's very compatible with open source stuff. Just use bits and pieces. So yeah, mainly working in healthcare. Yeah.
Hi everyone. So my name is Emel, and I'm AI engineer at InStudy. So basically what we do in InStudy is like doing lots of reinforcement learning, computer vision like tasks and everything. And what we do is we use, in production we use like Python. We use like Docker, Kubernetes for stack and CI/CD kind of things. Yeah, and I'm actually interested in privacy preserving machine learning. So we're trying to do like kind of things using privacy preserving machine learning techniques and tools.
Cool. Well, seeing as we've got people from all over the continent and lots of different countries, I just wanted to define what is an agony aunt, just in case anyone's not familiar. So here's an agony aunt. They usually deal with like relationship questions, like I'm feeling heartbroken and lonely. Here's an agony aunt that deals with hair questions. So that's what an agony aunt is, just in case anyone didn't know. All right, so on to the questions. Okay. Dear agony aunt, hope you can all read that. I'm experiencing growing pressure to put my ML into production, but it's been a nightmare working with some of the software engineers to do this. do you have any tips on handling this culture clash? So this is something that I see a lot because I work with lots of different customers in different industries. We have data scientists who might come from a statistics background, and we have software engineers who come from a C++ background, and they do not get on. And it's really interesting to watch the two sides fighting. So I think what used to happen in the olden days was that the data scientists would hand over some model, and then the software engineers would rewrite it in some efficient language. And we're kind of moving away from that, where the data scientist is more and more responsible for the end-to-end, actually putting their model into production. Keen to get your guys' thoughts on this, but that there's definitely been this cultural shift away from using languages that can't be put into production. And this responsibility is now on all of us. So I think there's a spectrum between, maybe on the far end of the data science spectrum is the pure statistician, on the other end, the software engineer, and we all fall in that spectrum somewhere. Like, that's all up to you where you fall. But I think the software engineers get annoyed with data scientists because sometimes they can seem quite arrogant. Like we know the best model, listen to us and do what we say. The software engineers look at them and say, your code is rubbish, it's got no unit tests. That's the worst code I've ever seen, why are you so arrogant? And then the data scientists get frustrated because they're like, these software engineers keep asking me to write unit tests and that does not make sense. So there's the massive cultural clash. But I think these two roles are just merging together, really. And it's important for, I think, this kind of community, this audience, to embrace these skills, like testing and like putting your code in a repo that everyone can access instead of having it on your own hard drive. And having stand-ups and having meetings with other engineers to tell them about the decisions you've made. So I think those are some kind of tips for everyone getting on a little bit better. Let's see what you guys...
So who's kind of had to manage a dev team here? Maybe one or two people, you can put your hands up, and manage maybe the interaction between these players. If in this position, what I'd recommend is sometimes you don't have to keep them separate. So you say you've got your data science department and they all group together, because it becomes a social problem, a people problem. And you got your devs and they'll do things together. And what I've seen work really successfully is that you actually work in pairs. So instead of having these two separate departments, you pair up one engineer with one data scientist, and they actually try to feed things to each other, and they review each other's code, and they build a bond that way. And that way you break that grouping of, we're the data scientists, we hate the engineers. We're the engineers, and we hate the data scientists. So that's a nice trick to try and get around that I've seen work pretty successfully. And if you do look at a lot of the big organizations, they often have kind of if you look at the research space, it's the research engineer and the research scientist, and I think in industry we could always do the data scientist and the data engineer, and they can work as a team. And I think splitting that up also works in terms of splitting up the workload quite nicely.
They have that in advertising, where they have an art and a copy working together on brief. There's one person who's writing stuff and the other person is doing visual stuff, and together they come up with advertising. And it has been the case for, I think, 75 years. That's been like the basic unit of a creative team in advertising. So it's interesting that it works in additional fields too, right?
That is an excellent analogy. Okay, I'm going to just read out the next one then. Dear Agony Aunt, my machine learning model has many bugs that the client has picked up. Every day he finds a new one. I feel like I'm missing something fundamental. Which one should I work on first?
So this is a real life case because particularly in production, your model is never perfect. And even when you think it's perfect, your distribution is probably not representative of what users might just go and do. So you might think you're building for a certain group of people who are likely to fall into certain, I don't know, many after our first release, and this happens. And to the client, it's a bug. And the problem is it's a very difficult thing, because I get it's a bug, but it's really hard for me to fix it. Like, if it's code, you go in, you write the test, you fix the thing, and it's probably done. You know, you might have to do a bit of investigation. With a bug, it's, you know, in an ML model, a bug, it's basically just that it's not working perfectly. You have to do a lot more. You have to go augment your data, probably retrain something. So the cycle's a lot longer. A bug can be fixed in a couple of minutes. Can I fix a machine learning model in a couple of minutes? Probably not. So what we found really useful is, because I had many issues about a year ago, we found really useful was actually putting into like a very stupid system. And the stupid system was as follows, is that as soon as the client, you know, it's basically a bug logging system for ML. Because usually, like, let's say it's an NLP, you'll find a problem with a specific area. You know, this particular group of, when we're talking about these sort of products, they don't work this way. Or we've noticed in these kind of exceptional circumstances in a health system, they don't work well. So we put in a bit of a bug tracking system, but we included a couple more metrics. So a bug would be, you know, not, oh, this didn't work when I did this. It's like, oh, it seems we have a problem with the word, with health issues in this case. So I'm working in NLP space, so let's say we've got a problem, it's doing things with doctors and drug dealers and it's getting very confused. And then we try and gather a couple of other instances of that. So the client will come up with one, then we'll say, okay, are there similar things? Have you noted similar issues? Try and test a couple of similar issues and try and gather a little bit more about this problem. What was really useful was gathering these extra patterns, and you add that now to your test set. You say, you need to be able to track what happens. You know, when a client says, is it fixed? I can point at a test if you're working from software. If you're working in machine learning, there's nothing you can point at. So what we try to do is we gather these test cases and we actually track how we're performing on our different bugs over time. So we can't, when the model's trained, we won't necessarily go, oh, here's the machine learning model, it's definitely solved that. It's probably improved by, you know, 30%, 50%, 20%. And maybe when it improved on one bug, it actually got worse on another bug. So being able to try to track these bugs, we can plot them out, you can plot their accuracies over time. That was really valuable. So when a client came to me and said, have you solved the drug dealer issue? I said, yes, we've improved 80%, by 80% actually on just that problem, and given our small sample size. And if we look at, and he's like, and how about the other smaller minor issue? And I'm like, we didn't improve that much. In fact, it got a little bit worse. And that gave a really valuable thing for him as a business person to say, you know what, that's way less extreme. This weird small issue. So I don't mind it got worse. This issue with the drug dealers we have to solve now. So that was important. So it kind of became first of all, exposing that to the client. And second of all, we kind of looked at it in terms of error times impact. Impact meaning how disastrous is the bug? How many people is it affecting? Like, how bad is it when it affects it? So if it's a really, you're being set up with drug dealers or something, that's probably not something you want to have. So that's really, even if it only affected 2 users, it's really bad experience for them. Whereas maybe something in a different circumstance, you could have something that only affects 1 user and it's kind of bad, but you've kind of got something you've solved only about 50% well, and that's affecting majority of your system. So the idea is that's kind of what we defined impact. We kind of tried to give it a number. We chose it as the number of users affected on the system, and then kind of we scaled that based on how drastic the problem was. And we multiplied that by the error. So if it's a really big error, then even if it's only affecting a small amount of the population, it's really big, maybe you should look at it. And that kind of scaled it down. So having these kind of metrics where you can say, okay, right now this is the most urgent one, was really, really useful for us.
I guess it's also good to plan to have bugs, because if you're working in a notebook with MNIST, nothing's going to go wrong. Like, what can go wrong in that situation? But guaranteed, as soon as your model is in the real world and real data starts coming in, some of the data will be unexpected. So you must plan for bugs. And so you need to think about deployment. Like, okay, so you've got a broken model that's out there that customers are using. Are you going to, like, branch off from your code, make a hotfix, and then deploy this new model straight into the production system? What if that goes wrong? So you can see why it's really important to kind of have versions of your code and be able to switch models in quickly and say, like, okay, we need to roll back 3 versions because the current model has got even worse bugs. So this question kind of highlights the importance of versioning models, versioning data, versioning code for when you definitely do have bugs. So, yeah. Nothing to add.
So many after our first release, and this happens, and to the client it's a bug, and the problem is it's a very difficult thing, because we like I get it's a bug, but it's really hard for me to fix it. Like, if it's code, you go in, you write the test, you fix the thing, and it's probably done. You know, you might have to do a bit of investigation. With a bug, it's, you know, in an ML model, a bug, it's basically just that it's not working perfectly. You have to do a lot more. You have to go augment your data, probably retrain something. So the cycle's a lot longer. A bug can be fixed in a couple of minutes. Can I fix a machine learning model in a couple of minutes? Probably not. So what we found really useful is, because I had many issues about a year ago, what we found really useful was actually putting into like a very stupid system. And the stupid system was as follows, is that as soon as the client, you know, it's basically a bug logging system for ML. Because usually, like, let's say it's an NLP, you'll find a problem with a specific area. You know, this particular group of, when we're talking about these sort of products, they don't work this way. Or we've noticed in these kind of exceptional circumstances in a health system, they don't work well. So we put in a bit of a bug tracking system, but we included a couple more metrics. So a bug would be, you know, not, oh, this didn't work when I did this. It's like, oh, it seems we have a problem with the word, with health issues in this case. So I'm working in NLP space, so let's say we've got a problem, it's doing things with doctors and drug dealers and it's getting very confused. And then we try and gather a couple of other instances of that. So the client will come up with one, then we'll say, okay, are there similar things? Have you noted similar issues? Try and test a couple of similar issues and try and gather a little bit more about this problem. What was really useful was gathering these extra patterns, and you add that now to your test set. You say, you need to be able to track what happens. You know, when a client says, is it fixed? I can point at a test if you're working from software. If you're working in machine learning, there's nothing you can point at. So what we try to do is we gather these test cases and we actually track how we're performing on our different bugs over time. So we can't, when the model's trained, we won't necessarily go, oh, here's the machine learning model, it's definitely solved that. It's probably improved by, you know, 30%, 50%, 20%. And maybe when it improved on one bug, it actually got worse on another bug. So being able to kind of track these bugs, we can plot them out, you can plot their accuracies over time. That was really valuable. So when a client came to me and said, have you solved the drug dealer issue? I said, yes, we've improved 80%, by 80% actually on just that problem, and given our small sample size. And if we look at, and he's like, and how about the other smaller minor issue? And I'm like, we didn't improve that much. In fact, it got a little bit worse. And that gave a really valuable thing for him as a business person to say, you know what, that's way less extreme. This weird small issue, so I don't mind it got worse. This issue with the drug dealers we have to solve now. So that was important. So it kind of became first of all, exposing that to the client. And second of all, we kind of looked at it in terms of error times impact. Impact meaning how disastrous is the bug? How many people is it affecting? Like, how bad is it when it affects it? So if it's a really, you're being set up with drug dealers or something, that's probably not something you want to have. So that's really, even if it only affected 2 users, it's really bad experience for them. Whereas maybe something in a different circumstance, you could have something that only affects 1 user and it's kind of bad, but you've kind of got something you've solved only about 50% well, and that's affecting majority of your system. So the idea is that kind of what we defined impact. We kind of tried to give it a number. We chose it as the number of users affected on the system, and then kind of we scaled that based on how drastic the problem was. And we multiplied that by the error. So if it's a really big error, then even if it's only affecting a small amount of the population, it's really big, maybe you should look at it. And that kind of scaled it down. So having these kind of metrics where you can say, okay, right now this is the most urgent one, was really, really useful for us.
I guess it's also good to plan to have bugs, because if you're working in a notebook with MNIST, nothing's going to go wrong. Like, what can go wrong in that situation? But guaranteed, as soon as your model is in the real world and real data starts coming in, some of the data will be unexpected. So you must plan for bugs. And so you need to think about deployment. Like, okay, so you've got a broken model that's out there that customers are using. Are you going to, like, branch off from your code, make a hotfix, and then deploy this new model straight into the production system? What if that goes wrong? So you can see why it's really important to kind of have versions of your code and be able to switch models in quickly and say, like, okay, we need to roll back 3 versions because the current model has got even worse bugs. This question kind of highlights the importance of versioning models, versioning data, versioning code for when you definitely do have bugs. So, yeah, nothing to add.
You might want to define them with 5 data points, right? Fine. When you're going to meet those humans, they're not going to fit your 5 data points because there's zillions more data points which you don't have access to. Humanity haven't discovered. You might want to define them with 5 data points, right? Fine. When you're going to meet those humans, they're not going to fit your 5 data points because there's zillions more data points which you don't have access to. Humanity haven't discovered.
And is there something simpler that could solve this problem? Like, can you just use an Excel spreadsheet, or just like a really classic linear regression will do the job? My job is to actually say, no, we're not using machine learning. There are simpler ways to do this.
Someone has to do that. No.
Probably the same thing that you have been said, but perhaps adding, like, if you don't have like a huge amount of data, just don't do that, because you'll be stuck with trying to buy some data, which is like when you're a startup or something, is like very unlikely to be able to do some kind of thing. So before jumping into client like project, just be sure that you have the data and the project is feasible before doing anything else.
Dear agony aunt, it's scary to put my model and data out there. What do I need to know about privacy?
Okay, so like Daniele said earlier, it's like there is lots of problem with like data, the things with GDPR and everything. So privacy is like very hard to get. So one of the things that I want to talk about is putting my model or my data in for everyone to use is like this is like for privacy, have privacy issues. And what do I need to know about privacy is like there are certain techniques that are used which is like labeled. So one of the things you can do is that you send your data to those people, and those people do the predictions on your own data, and your data is encrypted and then send back to you the results. This is done using federated learning or differential privacy. So for example, one of the things, federated learning has been introduced lately in 2016 by Brandon McAdam, who's like an engineer at Google. He said, like, instead of sending the data to a central server, when everyone basically at a certain company can see it, you send the model to the data, to the devices that exist. The real data exists in everyone's device, so we can make use of it. So it's like it exists. And with this technique, you can use the real-time data to then aggregate the results from the devices into a certain central server and do predictions on it. There's also like something called differential privacy. Differential privacy is like you have like you basically add noise to the data. So you have like the devices, and the device, like, you can encrypt some data, but people can do reverse engineering on them. But when you add noise, no one can do basically reverse engineering on it. And one of the things, things that you can use in differential privacy is that when, say for example, you want to add some noise, how much noise you are going to add in that amount of data. These are like other techniques, like mathematical techniques, to be added in differential privacy. So, like, this is like in, yeah.
I really I submitted this question for ML to answer. So I have a question. What is the impact on the business? How much does it add to the process? Like, how difficult is it to do? Does it make it take 10 times longer? Is it easy to do? Is it something we should be doing more often?
Yeah, so basically I think it's something that we should do more often, because you keep the privacy of the data of users, so no one can judge you or no one can tell you that you're using people's data. So it's like you're secure from anyone to tell you that you're using people's data. But right now it's very slow. The process is slower. It's more slower than normal machine learning. But with time, I think that we can like have more complex like building techniques that can be used to help like have a more powerful machine learning with privacy preserving machine learning.
I think these are great questions, and the next one follows on because, yeah, if you're working in your notebook on your MNIST, security is not an issue, but out there in the real world, it really is. Okay, are there specific tools for privacy in ML in production?
Yeah, so the tools I've been talking about, like there is in literature right now there is like 4 major or 5 major like techniques in cryptography. 2 of them were existed long, like from years ago: homomorphic encryption and secure multi-party computation. And then 2 of them are new, or 3 of them are new: federated learning, differential privacy, and secure enclave. Well, one of the things that to add is that not if you want to have like a powerful pipeline with privacy-preserving machine learning, you have to use not only one but mix all this technique together to have like a powerful pipeline. Because one of the things, like for example, if you use homomorphic encryption, which is basically like encrypting the data, doing the computations on the data, and then getting the result, one of the things that you can do is that do reverse engineering on it, and then you get nothing as a result. Or if you don't have the key for the homomorphic encryption, it's like this process is useless. So one of the things to do is, for example, to like combine, for example, differential privacy and federated learning together to have like a powerful pipeline for production. So I'll give an example here. But one of the things that is in real life application, everyone is basically using it, is the next word prediction in Gmail. So the next word prediction in Gmail is done using federated learning. So it was introduced this year at Google I/O by Google. So it's like this is a real world application when federated learning, when you do prediction, no one can know what are your messages or what are you going to write or something, but this is on your device.
Yeah. So are there any tools ready for people in this room to use for this, or is it kind of just in the future?
Yeah. Okay. So I might probably want to add, like, apart from the cryptography system that, like in real life, there is TAFE.encrypted, which is done by the Dropout Labs. There is also the Open Mind community, which is like GitHub. You can go see their GitHub repo, and they are also on PyPy. And they're doing like great job on top of PyTorch, using PyTorch with using federated learning, secure multi-party computation, and perhaps more after using differential privacy. I think, yeah, there's also the PATE framework that was introduced by Google lately in 2018. Apart from it, yeah, you can like Google or see more about OpenMind, Andrew Trask, Morten Dell, who is like the one of the guys in secure multi-party computation, and Brandon McAdam. Yeah.
And I should say, I think Microsoft has just released confidential computing, so it's still in preview, but they've partnered with Intel to make chips that have these enclaves. So like, there's literally no way to see someone else's data that is controlled at the processor and hardware level. And there's this whole confidential computing stack. I'm not a security expert, but it sounds interesting. Okay, dear agony aunt, recently I've been asked to write unit tests for machine learning code. Does unit testing even make sense in the context of data science? So this is something that really riles people up and causes a lot of arguments. So in my team, we've actually stopped calling it unit testing, and we've started calling it meaningful testing. So, because there's lots of arguments about like what is a unit in data science. So if you think of some TensorFlow code, like how would you unit test TensorFlow code? You don't want to be unit testing TensorFlow itself or unit testing Python itself. So it's kind of, when you first think about it, it might not be obvious how you can do that. However, we've recently done a project where it was actually an unsupervised ML project, and there was a lot of feature engineering. So, the usual dealing with missing values, transforming columns, one-hot encoding, that kind of thing. And those kind of steps you actually can unit test. So you can check that when I've done the one-hot encoding, if there are this many categorical variables, there should be this many columns added. You can do that kind of test. And we've also used like mini tables, because we were dealing with structured data in this unsupervised problem. So we'll have a little mini table for our unit test and say, okay, if this little mini table comes into this function, then I can calculate by hand, this is the number that should come out, and then write a unit test that says, whenever this table comes in, this number should come out. So that is like a bit different from normal unit tests, where you've got like a whole table coming in and out. And then we've also tried sort of what we've kind of called end-to-end testing for the featureizing, which is when this big table comes in and it's been batched and it's been featureized and everything, this is the table that should come out. So your units, I mean, the data you use for unit testing might be a table or an image or something, which is a little bit different maybe from normal software engineering testing. Yeah, what else?
So I've also found that, first of all, who knows what a unit test is? Okay, so we've got a lot of people. For those of you who don't know what a unit test is, it's usually just a way of writing code. So you write some code, you write a little test just to test that tiny bit of functionality. And the idea is you should be getting good coverage. You should be building up these tests as you add new features. What's a really good way of doing it is if bugs come in, you can write a little test to show that the bug exists, that you've identified the correct cause. And then ideally when you've gone and fixed it, you show that the test passed. So there are lots of systems for people who aren't software engineers yet. There are lots of systems and tools and ways of doing it. And it's kind of like a thing you get taught. There's entire fields just about doing TDD. Giving a nice example of why this becomes really important is often the devices you're testing on or the devices you're training on are not the same places you're going to be actually deploying the system. And a good example is someone who's running these on-device models. And I've heard horror stories of people who've, they'll change, as you say, add an extra dimension, and in the training area, and then now they have to come and deploy it. And the deployment is very interesting because now they're deploying configurations of, we've got an extra feature on the device, you need to download this, there needs to be some in-sync, you need to be syncing between multiple teams. So as the Android developers need to know what they need to do, the other teams need to know what they need to do, and if you're changing things without actually having tests of what's coming in and out, then there's no way for them to know unless you explicitly tell them. And it's a lot easier for them to have tests that will fail if their system no longer works. So that was a really good example. I thought of where this becomes vital. And I think sometimes if you're struggling, if you're trying to work with data scientists who seem to be fighting back, showing them the value of something like that, they'll suddenly go, oh, of course, yes, that makes absolute sense. I will definitely write those meaningful tests. Yeah, and you can run unit tests on data. This is what I started doing. If you've got a lot of data that's coming in, data changes. So knowing when your data is going wrong, even if it's something you do once a day, you just pull in a sample, run something on it, so basic checks of distribution, basic checks of like the numbers. It's really useful to know, even in kind of like a way that's fuzzy. So you don't have to know that, all my 100% of my unit tests are passing, but it's good to know that, hey, 80% of the patterns coming in are null. Or 80% of the, we've had a change in a distribution, and suddenly we are, the bytes are looking a bit strange or something. And being able to plot that, you can kind of monitor the state of your data over time, which is quite nice. And it's a little bit different from like a binary kind of, you want to run a set of unit tests, you're kind of tracking these tests on your data continuously.
I think if you're doing a PhD, you might finish your PhD, your code stays on some old hard drive, and you leave, and no one ever uses it again. That's very different from working in production in a team. So it's important that if someone picks up your code in 5 years, and they're like, oh, what was this section for? This looks like rubbish, I'm going to delete it. They need warnings to say, oh, you just made 5 tests fail, do not do that. It's really important for maintaining. Another thing is, it's sometimes helpful to distinguish between 2 different phases of data science. One is an interactive exploratory phase, where you don't have to write unit tests. You can, it's good, but you don't have to. You're just exploring, you're tweaking parameters, you're looking at graphs, and you're getting like a qualitative feel of what hyperparameters to use and what features to use. And then there's the production side, where you want all of that to be automatic. You don't want any humans in the loop that have to look at graphs and make decisions. And when you're working in a software engineering team, there's going to be different components in the system. There's going to be security and authentication, front end. So when you work in the software engineering team, they're going to say, okay, data scientist, what are you going to give me? You're going to give me a model. And that model has to fit into this whole ecosystem. And they're going to say, we've got unit tests for everything in the system. Where are your unit tests? So you don't need to freak out and write unit tests for all your exploratory stuff. In fact, you can keep your exploratory stuff, potentially, keep it in a notebook, or keep it in a separate repo. They don't care about that. This is the trick that I've learned. All they care about is that model that you give them. It's maybe like a pickle file, like a serialized model, or like a Flask app, or that's all they care about. So that's what goes in their repo. It's just that artifact, and that's what has to be unit tested. To say, okay, the model is expecting 5 fields as input. What happens if 6 fields come in? That's the part that you need to unit test. And that was like a real revelation to me when I realized that the arguments were actually about unit testing that artifact, not all your exploratory stuff. Okay, dear agony aunt, I'm concerned about the direction my project is going. When is the right time to talk about ethics? Is it too late, I guess, in production? Is it too late to talk about ethics?
There's always a question about ethics. I'm going to be the one answering that question first. So, actually, in the point I was making before, about 70%, 2/3 of data scientists dealing with deep learning are actually part of research and development department. In the same report by O'Reilly, there was a point about what are the priorities for your team this year in terms of where you're going to take the direction of the machine learning, the production. The first thing that people were concerned about was transparency, and the second thing was actually ethics. So it's a trending risk that we should actually take into account. There's a, let me find that, there's like a, one of those organizations which have created like a manifesto for that, the Responsible Machine Learning Principles. And this is by the ethical.institute/principles. And it's very nice, they thought about it, so we don't have to. And there's 8 points here, which you can check in your own free time. But the point is that because there's so much conversation around it, there starts to be a little bit of a consensus of what it is. Those guys would argue, of course, you have to do it from the beginning. I think it's a little bit unrealistic, to be honest. I think that a lot of the ethical questions have to start when you try to find what's the problem you're trying to solve, and at the feasibility level, there's probably going to be some issues as well. And then there's common sense, right? And common sense says you have the data, you could do the research, you could create an application. Do you have to do it, right? So I used to work with the Cambridge Psychometric Center in 2012, which is 2 years before they became infamous for something happened with Cambridge Analytica. Because we said, okay, I'm going to talk a bit about those guys now. I just want to say for the record that the data is bullshit, and what they say they can do, they can't. Okay. They didn't influence the American election. I saw the data was a 2009 static database of likes. Okay, and they used that to so-called predict people's personality, which is not true. They couldn't predict it. And what they really did, Cambridge Analytica, is just get a lot of data, which wasn't illegal, and just buy a lot of cheap ads. Okay, so the Cambridge Psychometric Center had really bad data. Now, that's not the question. The question is, let's say you have the data, and let's say it could be used to influence the election. do you have to do that? Okay, so I mean, I think independently from the fact that there's slowly a consensus about what ethics means and when to address it, there's also like just common sense, just don't be an asshole, basically. So, pardon my French again. Yes. What do you think?
And the hard thing here is to acknowledge that not everyone is privileged enough to take on their organization, right? You can't getting fired from a job because you stood up for ethics and you can't support yourself. That's really, really hard. And if you talk to some people, they're like, no, just leave it till later. And what I'm saying is, you don't have to make, at the beginning you don't make a big noise. And you grow your little bit of noise. And you talk to other people and you slowly grow noise. Because that's how it works, right? You build this critical mass of people who are pushing against it. If you just come out and say, I'm going to do it, you might get fired. But if you inspire enough people around you within the organization to have an issue with it, it might work. It's hard for an individual to take on a large, giant corporate, but it's easier to do it in a slower way. And if you get there, and if you keep going and you start raising, sometimes it's even better to be on the team that's doing it because you know what's going on. This is also sneaky politics. Sneaky politics, raising it in the concerns of like users, and you do that slowly over time, and you get louder and louder, and people get louder and louder, and eventually then something changes. So it's a very hard thing to fight, and it is hard to fight by yourself. And you don't want to be dismissed by just coming out and being like, I will never work on this is terrible. They'll be like, cool, well then you don't work on this project, bye. And then you're in a place where you can't necessarily even make change. They will continue doing what they're doing, whether or not you're there. There will always be someone who's willing to do the work you're not willing to do. So like sowing the seeds of concern in the organization and making it grow bigger and bigger. When you have enough power, being able to start standing up. Something Bayo said earlier, this was in a totally different context. It was, prove yourself to them. So start showing them here's why it's unethical. This is why it's a problem, and grow your mass. And then by the time you've got enough people on board, someone higher up is going to listen to you because they don't have a choice.
You should be talking about ethics in the beginning, but it's not too late to pull something out of production if it's unethical. You might only realize that once it goes into production, because when you see real people interacting with it and you see how it really performs in the wild, that might be the first time you realize this is creepy and unethical. So definitely, it's never too late to just stop doing something bad.
Well, I think you probably know this quite well. What about the case like with Microsoft? I think a lot of the engineers objected to the work they're doing for DARPA, and Microsoft was just like, thanks for your concern, but you're going to do this anyway. What are your thoughts on that?
So I'm not a PR person. I'm not a spokesperson for Microsoft. I don't represent them. I'm just representing my own views. So I believe that after that pressure, Microsoft did stop that contract. I know there was okay, this is off the record. I'm not, because I don't know all the facts here, but I believe it's quite normal for big tech companies to sponsor, what's it called? To sponsor American politicians. There's a special name for it if there's any Americans here. It's called like... No, not lobby. It's called like CAT or CAB or something like that. And it's, I think it's CAT. And it's normal in America for big tech companies to sponsor politicians. And until a few months ago, all the tech companies were giving like billions to politicians, and then they can, so if you give it to the Republican Party, they can do whatever they want with that. And then recently, I think Apple and Microsoft pulled out. They pulled out billions and said we're not funding this anymore. And this is while they're trying to compete. Microsoft is trying to compete with Amazon for a massive government account, and they pull out anyway. So I thought that was quite cool. They were willing to lose business over this, so I thought that was quite cool. But like I said, I'm not an expert on what Microsoft is doing. I don't represent them.
Sorry, thanks so much for the panel so far. Just a question. Have any of you had personal experience where if something does go ethically wrong, that pushback goes to yourselves in production or those individuals working on the problem then to the PR individuals? Have you ever felt that pressure coming back to yourselves as a development team?
Always get blamed.
It makes up a very bad integral conversation after that with your family.
AI have you?
Yeah, have you? I'm interested to hear. That's
No. I was just wondering at larger companies.
no, I haven't personally experienced that. That must be really tough. Who takes responsibility for a bad ethical decision? Yeah.
I would refer back to what's his name, World War II, and what they did, and actually Ruha's talk, where they split the bits up so much that no one felt individually responsible for any one or thing. And if you ask people from World War II, they said I put people on trains and I sent them to where they were meant to go, and that was my job. I was doing my job, so it was okay. And yeah, it will come back to bite us. It probably, like, I have heard of it coming back to bite the developers, but it usually, in the structural world, people do take it higher and say, no, someone else should have done it. But I do think we should take responsibility. We should have the ability to start speaking out and spreading the little words. And yeah, I haven't heard of anyone where it's actually come and hit the developers and they got fired. If that's helpful, if you're worried.
No, I haven't experienced that either. Only the Cambridge psychometric one, as I was saying, awkward dinner table conversations, but that's pretty much the extent of what I had to pay for working with on that project.
Okay, nearing the end now. So I'm feeling frustrated that my PhD did not prepare me for how to get my ML models out in the world. Did I miss something? So I think that's not...
Who feels that way?
Does anyone currently feel under-equipped to actually put something into production? Yeah, so I think, maybe some PhD programs do teach you practical skills, but I think a lot of them are just very theoretical, even from great schools. So there's nothing wrong with your university. I think that's probably most universities. But I think something Jade and I were talking about earlier was that, and I think there was this massive hype wave of like hiring data scientists. And after a year or two, the business units are coming back and saying, so what have you guys done in the last year? Oh, you've got 2 notebooks. Okay, that was not a good investment. Like, they want to see what is in production. So teams are actually starting to be a little bit more accountable. Like, I think maybe the golden age of being able to do whatever you wanted are over. And there's more accountability now as like the rest of the business wises up. And they're like, yeah, you haven't actually added any business value with your notebook, so it's time for a reckoning. I don't know, have you guys seen that?
The one thing I wanted to add here was, did I miss something? You didn't miss something, everyone missed something. I come from a complete software engineering background. You think I would have known what to done, at least from the software perspective, on some of these challenges. And sometimes you look at all these great giant tools. I mean, the amount of time I spent fighting with like these CI tools and these DevOps tools, and just being flabbergasted. We've got some of the most senior engineers in the team being flabbergasted. So if you're feeling like, oh my gosh, there are all these tools and there's so much stuff and I don't know it, it's okay, you'll get there. Just pick one and start with it. It's actually not as hard as you think it is. It's just a little bit of a fight. And if you're fighting and you're feeling like an imposter, everybody is, because no one actually knows how to do this in like a step-to-step way. That's why this wasn't a step-to-step talk. We can only give you like a recommendation. I think alone we are all very unequipped trying to talk to as many people, and that's why having a good bond with your engineering teams and learning from them and teaching them is like a good way to like sort of start growing that, because they've probably had some of these fights before.
Yeah, and to add to that, the tech stack moves so quickly. That's why we didn't want to give you a list of like, this is what you must use, because it'll be outdated next year. So it's this constant frustration of like, oh, that tool I was using is now being overtaken by something more efficient and more wonderful. So that is frustrating, and you constantly feel like you're missing out. And this field is really new. Software engineering is developed and mature, and there's a set of practices just like the rest of engineering. Like, you don't just go and build a bridge without some regulation and testing. So software engineering is a bit more mature, but machine learning is just like Wild West when it comes to production. So I don't think there are industry standards and practices. It's something that is currently being defined. So actually, if you're interested in this area, it's wide open. Like if you want to suggest the best way to put stuff into production and to collaborate, it's people are looking for answers. Yeah.
Yeah, and we have like half an hour. So got, yeah, about 10 minutes at last one, and then we've got 20 minutes.
So we could do some.
Just two, yeah, no, like 30 minutes.
Is the other speaker around?
Yes, Brian, are you there? Oh, yeah.
Okay.
Cool. Yeah, we should probably wrap up so we have time to listen to terrible and creepy, horrible mistakes and just nice challenges that people had at work. But first of all, maybe we can take just a couple of questions and then, yeah,
Any questions from the audience?
a question there.
Do you want to? I'll repeat it.
Yeah, the question goes on about, as you say,
My question just relates to some of the last comments you had about tech stacks. The field moves so, it's very fluid, it moves very rapidly. When do you know that you should actually move on versus keeping the stability of your current stack? What would you say is a good metric for that?
That's a very good question. So the trick is, I believe we develop stacks faster than we could ever keep up. And I think leaning on we're doing okay for now is good. So like, in our projects we regularly do this. Like I think we've written our current stack 3 times, but not just the ML stack, the entire app 3 times over the years. And for us, if what was important was keeping up to date, but not necessarily putting it in. And it's sometimes good to know what you're missing out on. So usually those new tools solve like a really big problem. So that's the one aspect, is like, look at the new tools when it's solving something you can't currently solve. That's a good metric to use. And the second bit is like, I would always say like a couple of years, because things can completely change. But we can't change every year, we'll be rewriting too much. But at the same time, we can't get things to become legacy. And there's still things that are supported now. So my system, I don't use Kubernetes because I never needed to. I use Docker and some Travis, and that's it. And for a long time, we weren't even using that. It was a simple stack. It didn't have to scale that much. And I think that's, okay, don't just run to the new tool, because Kubernetes sounds like the greatest thing in the whole world. It's a big learning curve, right? So yeah, so there is a bit of a balancing act. And I'd say, yeah, when 10 years is too long, 5 years is probably too long, 2 to 3 years feels like a good time to pivot. By then you've added a lot of value, and you're seeing progress. But definitely don't try to keep up with the latest thing. Like stability on a production environment is important. So when you can add more value and that value is worth it, then switch.
Another question, or should we move on to terrible nightmare and catastrophes?
One more here. Okay, so I've just finished my bachelor. Okay, I know how to build models, do the math, do the stats and stuff, and so I have my Colab notebooks and stuff. But then when I'm applying to jobs, you find those weird requirements. They want you to do data ingestion and warehousing and do those pipelines and designs. All of those stuff on the side that comes before and after your model and the lifecycle production. So my question now is, should I focus at this point on learning those weird stuff, or should I just keep or invest the time on enhancing my machine learning and AI skills?
Maybe I can answer that, because I've had some experience dealing with exactly that kind of problems. I would say 70% is about knowing how to think, and 30% is about extremely applied, super fashionable stuff you need to know right now. Especially in engineering, right? So I mean, solving problem is solving problem. There's ways to think about a problem. It takes a while to understand that, so that's why it does like this whole AI, machine learning, intellectual exercise. But then, to your point before, I mean, you do have 2-3 years studying, right? So I mean, within those 2-3 years, it's probably a good idea at some point toward the end to start looking at what's trending, on GitHub and stuff like that, and just get a general idea of what most people will actually be using in the past 3 years. Most people who write job descriptions are not tech people, and they have no idea. they have no idea. They just copy paste it from somewhere, and they have unrealistic requirements. We've actually analyzed the amount of occurrences of stuff that really shouldn't be there. I mean, there's just like, it's only outliers, right? You should know like Kubernetes and Photoshop, and I don't know. I mean, this is like and so I wouldn't be too impressed about the shopping list. I think that, look, you've learned how to think. That's the most important. You've made yourself aware of the latest trends, so if you work with other engineers, those are probably the things that they most likely will be using broadly. And probably in terms of selling yourself, I would say, look, talk to anyone, just call them, okay? Just don't send your CV, just call people, go and meet them at events that don't actually read your CV. Call them directly and tell them, I have 60% or 65% of the skills you've listed on the CV, 20% is unrealistic, the other 20 I can learn within a year. When do I start? You know, something like that. Look, can I suggest, guys, that maybe we keep some questions toward the end, because it really would be great to hear from Brian and Kinandri. If that's okay, we start a little bit later, so maybe we can just take like